So this is one of the AQA required practicals, making a salt, and from a solid oxide, solid metal oxide here, copper oxide. Usually use copper oxide because then that gives you a nice coloured solution of blue copper sulfate and makes it a bit more interesting. Add sulfuric acid to that, and you end up with blue copper sulfate solution. And you also, so that's the salt. So this is the base. This is the acid. And you get salt and water. You could do it with magnesium oxide, say for example, Mg. Okay, but that's a bit more not as interesting because the salt colored is colorless solution. And instead of using sulfuric acid, you could use hydrochloric acid. So the salt you'd get then would be magnesium chloride, aqueous solution, and H2O. I need to balance that with a 2 there. So you can do, but most people probably use copper oxide because it's a nice, makes a nice colored solution. So what you do is you've got a beaker of sulfuric acid there, usually about 1 mole per decimeter cubed concentration. It's an aqueous solution, and you're going to add the black copper oxide powder here in the spatula. Right, so you the reaction isn't that quick at room temperature, so you usually heat it with a Bunsen on a tripod and a gauze. So you heat it, and right, so you add the first couple of spatulas of copper oxide, and it will go clear, and that's because all of the copper oxide is insoluble in water. All the copper oxide has reacted. Now, we want to make sure, you want to keep adding the copper oxide until it is in excess. Okay, so you add more copper oxide powder. How can you tell when it's in excess? Well, you can tell when it's in excess because you'll end up with some unreacted black powder at the bottom of the beaker there. So the first few spatulas you put in, it will go completely clear because there's still some sulfuric acid there, and the copper oxide powder isn't in excess. You keep adding it until it is in excess. Now, why do we add excess? That's quite important, okay, to think about that. Why do we bother adding excess copper oxide? Well, if you didn't add excess, well, what you'd have, if you look at the products you've got are, you've got copper sulfate solution, and, well, the reactants, you've actually got sulfuric acid, that is in solution as well. So you've got these two things are in solution. It's very difficult to separate two things that are dissolved in the same solution. It's really tricky. And so what you will have there, if you don't add excess, you're going to add you'll have a mixture of copper sulfate with some and sulfuric acid. And that's actually pretty bad, because when you come to evaporate it, well, what's going to happen to the concentration of that sulfuric acid? It's going to get stronger and stronger and stronger, which isn't terribly good anyway. And also, you don't want a mixture of copper sulfate and sulfuric. You want pure copper sulfate. So what you do is you add excess copper oxide, and that will use up all of the sulfuric acid. So the sulfuric acid will keep reacting, and the more copper oxide you add, and eventually, when it's all gone, the copper oxide won't react anymore, and you're left with some left over there at the bottom of the beaker. And at that point, you know you've used up all the sulfuric acid, right? So what we have to do now is separate the excess copper oxide, which is actually very easy to do because you're separating a solid from a solution. So all you've got to do is filter it. So here's a filter funnel, and the paper there, and you put your mixture in there, and the copper oxide, unreacted copper oxide, is going to be removed. It will remain in the filter paper, and you throw that away. So what you end up with is you end up with an evaporating basin. You filter it straight into an evaporating basin, or with copper sulfate solution, and then Very often it's a 6-mark question asking you how to prepare this salt. And one of the mistakes that people frequently make is they say, well, once you've got the evaporating basin, you just keep on heating it until you've boiled off all the water. Now, you shouldn't do that for 2 reasons. First of all, you might get some thermal decomposition of the copper sulfate. You'll get too hot and it might thermally decompose. Also, you'll get, if you evaporate the water very quickly by boiling it, you're going to get very small crystals, and you don't want small crystals. You want some nice big crystals. Okay, so instead of heating to dryness, you don't heat to dryness. You just heat to remove about half the volume of water, half the volume of solution. And then all you do is you leave this in the lab somewhere, and what will happen is once there's not enough water and you've got a super saturated solution, then crystals of copper sulfate down here, they'll start forming. And if you do that slowly, you get nice big crystals forming rather than lots of little ones. And then before all the liquid is evaporated, you tip off the excess liquid and you dry those crystals between 2 pieces of filter paper, and you've made your pure crystals of copper sulfate, the salt. Okay, so important things again is you add excess copper oxide. That's important to make sure you've got rid of all of the sulfuric acid. And then once you've got your copper sulfate solution, you don't heat it to dryness. You just heat to remove about half of the volume. Okay. Right, there are other ways of making a salt. So you can also make copper sulfate. For example, instead of adding copper oxide, you can use this green powder here, which is copper carbonate. I'll just write down the equation there. So the equation for copper carbonate is reacting with sulfuric acid. It's very similar. So when we had copper oxide solid plus sulfuric acid went to copper sulfate in solution and H2O liquid. Right, this time we're going to use copper carbonate, and that's also a solid, an insoluble solid. Add sulfuric acid and you get copper sulfate again. You get water again. The only difference is you also get carbon dioxide gas. If you look in here, right, there's the carbonate. So the carbon goes to the carbon dioxide. 2 of those carbon oxygens in the CO3 go to the carbon dioxide, and the other one goes to the water. There's a very similar reaction to the oxide. Now, because it gives off carbon dioxide, during the reaction, you're going to see fizzing. And you can tell when you've added excess copper carbonate, you want to add excess again to use all the sulfuric acid, because when you've added excess, well, just like the copper oxide, you're going to have green powder at the bottom. Copper carbonate, the green powder remains, and also the fizzing will stop. And then once you've got your the solution with all the sulfuric acid reacted, you just simply filter it like you did with the other one, evaporate it down to about half of its volume again, and wait for the crystals to form. So that is required practical, and it's a very common 6-mark question on the papers.